Good morning, students. In the previous class, we came to know about the what is meant by a CAD, what is meant by a CAM, how the design process will be there, uh, and what are the sequence of design process, and how to model the design, and we have seen how the problem will be solved from current design problem to selecting the evaluation and choosing the correct solution to that particular problem. And I have given an example how to reach from one place to other place and how to choose the best solution. So in this today's class we will learn about role of computers in design process. So I have divided it like this. So in this before that the CAD how it will be, here you can able to see, and here you can able to see in blue color the conceive, design, develop and manufacturing. There you can have the validation. So apart from this, there you can see a orange color line which intersects all the five requirements, that is the conceive, design, development, manufacturing and validation. This is the first one is the in the concept design. We are having the idea in the concept design. From there the concept design, and again it will be sent to a detailed component and modeling through product layout. For this product layout again there will be a requirements, and from the detailed component again we will be having divided into tool design, engineering, drawings, analysis and assembly modeling. So this is the complete how the CAD CAM will be there. So what is the task of a computer aided design system is, one is the geometric modeling, next one is the engineering analysis, third one is the design review and evaluation, fourth one is the automated drafting, and fifth one is the parts classification and coding. After manufacturing or before the manufacturing, we are going to divide the part or manufacturing sequences based upon the classification and coding, which this parts classification and coding you will learn much more in detail in computer integrated manufacturing. Okay, so before that, what are the CAD tools that required to support the design process, and what are the CAD tools that you need to have? So we have seen the design conceptualization. Design conceptualization is the concept. Next is the utilization. When we combine these two words, the conceptualization comes. For this, what are the CAD tools that are required? For the design conceptualization, we need to have the geometric modeling techniques. Geometric modeling techniques, again we will be having the constructive solid geometry modeling, boundary representation modeling, and these are the basic two types of modeling techniques which we are using. For this, the graphics aids software like various tools, like yesterday I have told you about the Pro Engineering, CAD and all those things. And these tools need to have the manipulation, means we can able to change the data. All the data, whatever the 3D model we are going to develop on the screen, it is based upon the values. That is the again we need to go for the lower end based upon the C language and all those things. Before that, bit to byte and how the data will be stored based upon the 0 and 1 values. Next is the visualization purpose, for better visualization how it need to look. Next is the design modeling and the simulation software. So we need to get the we need to model the components. One is the animation. Animation is nothing but how the how the parts will be animated, means how animation means how it rotates, or how the component moves, or how the parts moves with the other part. And assembly we can able to see during the assembly process. Suppose example, I have if example generally for the students I give is if there is a contract work of big road, one road will be done by other person and some other road will be done by the other person. Both the ideas are very correct, but this road will not touch this road because due to certain communication gap between these two roads. So what need to be, so that vehicle will not be moved because the two roads are at a different location. When these two roads will be equal, when we are having the perfect coordination, so the both roads will be equal, so that the work can be distributed and can be done fast. That is the example what I will be giving to you. So the same as above, we need to have the animation. Assemblies why we are going to see in the 3D modeling is we need to see the component, how the assembly. So different assemblies will be there in a car also. So how each assembly will be there, that you need to check it. And special modeling packages also will be there. Next is the design. Next is the design analysis. So once we have done the product, next we need to go for the analysis packages. We need to analyze the product, that whether the product can be able to withhold with the stress limits, whether the product that we have developed is in position optimized one, whether alternative materials can be used, or whether the component that was used can able to withhold the temperature in the atmosphere or the where the work generation will be there. That we are going to calculate the design analysis. Next is the design optimization. What is meant by design optimization? The design optimization means once I have designed one component, so we need to optimize it. Optimize it means maximum features that the component need to have and maximum work can be done. Suppose if an example, in early days we are having only the screws. Now there was a development of star screw. For this we are doing the screwdriver. When there was to this screwdriver, both options will be provided. Once if you turn at the one end, it will be the star driver it acts, so that it can able to rotate the star screw, and the other side there will be only one where it can be only one operation. Just 1 minute. Hello. చెప్పు సుబ్బాడి ఉన్నాడంటారా? ఓకే సుబ్బాడి, ఒక అర్ధగంట తర్వాత పోదాం. ఒక అర్ధగంట తర్వాత వెళ్దాంలే క్లాస్లోనా. Next is the design optimization. We need to optimize the product. So that comes. Next is the design evaluation. Sorry, I have forgotten to tell you. So the screwdriver in the earlier days is to do only to make the screw on the component. It's of only one type. Now due to certain star screws are also generated. So the screwdriver, when we move the screw from the tool holder, the one side it will be having the star screw to remove the star screws, and the other side it will be having the to remove the general screws or to tight or fit. Both can be this can be treated as an optimization. So next is the evaluation. What is the evaluation? So I have done the product. I need to check the dimensioning of the product, whether the product can be done with accurate position within plus or minus tolerances, and bill of materials need to be generated, and numerical control is the thing. Next is the design communication and documentation. So this design communication and documentation also plays a major role. For the design, whatever you have done, it need to be in a drafting form, that is the engineering graphics or machine drawing form, where the drawing can be easily understandable. It again depends upon the type of a drawing person, how it can be easily drawn and need to be understood. It is engineering graphics or machine drawing is nothing but a language to the mechanical engineers to understand the product, to understand the part, whatever it may be. So this is the design communication. And documentation. Documentation is nothing but we are going to give the complete details about the part or a component or an assembly in terms of a mechanical drawing sheet, and we are going to provide the detailed list of that particular product. Next is the definition of the CAD tools. Now what are the required CAD tools we have discussed. So for that we need to know what is meant by a CAD tool. For this CAD tool I can combine, it is a intersection of computer graphics concept, means the computer graphics, the computer science students will know about much. It is the intersection of that computer graphics concept. Next it is the intersection of geometric modeling and the design tools. When it is the intersection of the what is meant by a CAD tool, if anyone asks, we need to answer it as a, it is the intersection of computer graphics concepts and geometric modeling and design tool gives the CAD tools. So this design tools per and computer is equal to a CAD tool. What is the design tools? So what is meant by a computer? Computer is nothing but a CPU, monitor, keyboard, mouse, whatever it may be. That is the hardware which is of a control unit, and the display terminals, that is the input and the output devices. This is called as a CAD tools. Whereas the software, that is the which we loaded into the software, example like a Microsoft Office and all those things. So here is the graphics modeling software we are doing, and the applications programs we are going to use it. Next we come to the computer-aided manufacturing. What is meant by a computer-aided manufacturing? Before that, I would like to tell you how this you need to understand what is meant by a computer-aided design. Just a brief about the terminology. So the use of computer methods to develop the geometric model of the product in three-dimensional form, such that the geometric and manufacturing requirements can be examined. So that is the CAD, computer-aided design. This is you can take this as a one of the design, one of the definition. Next is the computer-aided engineering is nothing but use of computer methods to support basic error checking, analysis, means we need to analyze it, optimization, we need to optimize it, and manufacturing etc. of a product design. This is one of the definition. Computer-aided manufacturing generally refers to the computer software used to develop the computer numerical control programs for machining and other processing applications. We will see what is meant by a computer-aided manufacturing just now in the next session. There is one more software called as a computer-aided process planning. Generally it is called as a CAD. The use of computers to generate the process plan for complete manufacture of products and parts. So the computer aided process planning, what it gives that which part, because to manufacture a single part there will be large number of different number of machining operations that the workpiece need to go before it delivered to the customer. So at a time, on a single machine I cannot do all the operations. For example, if it is in a lathe machine, on a particular part, on the lathe machine I can only reduce the size. Suppose if I want to the grooving also, I can able to do. Again, what I need to do after reducing the size of the component with the lathe bit, if I want to groove that particular workpiece, again I need to go for the grooving operation by changing the tool on the same lathe machine. So this makes the large this makes a time waste. So what in big companies will do, here the one operation, only that machine can be used for only one operation. Immediately it goes to the some other operation. The next operation can be done on the some other machine. So this reduces the time to reduce the product production. So that because when a company is there, then each and every machine need to be worked in a optimized form. Okay, optimized utilization machine will be the optimization. Maximum time it need to be used with highest efficiency. If you see in the companies, they are going to calculate the efficiency of that particular machine. Okay, so next is the computer aided tool design. The computer assistants to be used for developing the tools to manufacture such as jigs, fixtures, dies and molds. So there is one more software developed, that is the computer aided tool design. So up to now we are having only the we are developing the part, we are developing the analysis of that particular part by changing different materials. We can how the structural analysis, thermal analysis, like this. Based on this we optimize the product we are going to do. Then the computer manufacturing software we are going to send it, and computer process planning, how the sequence of the parts need to be produced, need to be gone through the different machines. For this process plan, it is called the process plan chart is going to be generated. But whereas in the computer aided tool design, the computer assistant can be used to develop for the developing the tools to hold the component, to hold the workpiece. We need to have a jigs, fixtures to hold the workpiece as well as the tool and other accessories. So how this need to be, that also we are having various softwares, that is the computer aided tool design softwares. Once the all these things are there, once the organization produces the parts, next it go for the computer aided quality assurance. So whenever we go for the product, we need to check the quality of that particular component. The use of computers and computer controlling for accessing the inspection methods and developing the quality control and assurance function. We need to check the quality assurance, how the assurance we are going to give it. Next is the computer aided testing, refers to the software tools that can take a system through its various phases of operation and examine the response against the expected results. So these are the things. So design activities need to be well organized. The design activities need to be organized well and should take into account all influencing factors that are responsible for the success of the product. So to produce one good quality product, we need to arrange the various, we need to take the precautionary measures from the idea stage to the production stage. For this, a large variety of responsibilities will be there. Ideally, the designer should consider all these factors while finalizing the design. What is that? Product engineering and manufacturing engineering. What is meant by a product engineering? So, various functions already we have discussed, that is the product functions and specifications, conceptual design already, aesthetics, standards we need to follow, detailed design we need to give, simulation operation we need to perform, testing and the analysis. This comes under the product engineering group. Whereas the manufacturing engineering, we are having the process plan, where we need to generate the process sheet, route plan we need to generate, and tooling, what type of the cutting tools we need to be used, what type of jigs and fixtures are used to hold the component, and the tool that we need to have, that is nothing but the tooling. Part programming. Part programming is the robot program and CNC programming. Various types of CNC machines are there, and robot is also used, which was used to hold the components. Nowadays robotic technology became the more popular. Next, the production planning, it is requirements of bill of materials, material requirement planning is also there, and marketing and distribution is there, along with packaging. These are all are different specialized subjects. When we go for the higher education, MTech, then computer aided process planning is different. Tooling, computer aided tooling is one of the CATD, Central Institute of Tool and Design. When I am pursuing the MTech, this computer aided tooling was the evaluation at the time. So there was a great demand at CATD in Balanagar. So it was they introduced a course with Usmania University, and those days this computer aided tooling experts, specialized faculty, specialized persons used to get a greater packages. Leave it. Next is the part programming, production planning, marketing and distribution. So in the stages of the product design, problem identification and recognition of need, problem definition and conceptualization, and geometric modeling and spatial analysis. See, you can able to see the arrows. Each arrow was linked to this same thing. So here the geometric modeling and analysis and the production problem definition, and each one you need to treat as a different departments. There are around 3, 4, 5, 6, 7 departments is there. In each and every stage, these 7 departments, the 7 departments need to be coordinated to produce the product, to implement it. So that is the thing. Next is the problem definition. What is meant by problem definition? Already I told, problem identification and recognition of need. That is the statement of a problem itself is the greatest problem to us, to the engineers. First, we need to get the historical information. Historical information means if there is a particular phone, earlier phone how it will be, that earlier how people used to call, earlier how the 2G phones are there, before that pager are there, before that landline was there, before that what is the communication, that all the data you need to collect it, and to every problem there will be one general solution, it will be given. So that how this general solution to that particular problem we are going to calculate, we are going to choose it, and requirement specification, that is the what the customer is expecting from our product that we need to be generated, and what is the market forces, how the market and the competitors are available. So this is the problem identification. Next is the problem definition and conceptualization. What is the problem definition and conceptualization? So once that problem identification was there and the statement of the particular problem was given, then we are going for the preliminary design, how this particular product looks like in the computer screen, and preliminary sketches automatically will be generated based upon the preliminary design, and brainstorming ideas will be generated again in this stage, and we need to evaluate the designs, how the designs are produced, that we need to evaluate. Next is the geometric modeling. So based upon our software and the spatial analysis, geometric modeling is nothing but the creation of the three-dimensional components or parts or assemblies. Next we need to comparatively evaluate those, and we need to, with the help of the computer graphics, we can able to visualize those components clearly, whether there is any intersection between the two parts or components, and during the after assembly process there will be any intersection between the two or more assemblies, or when the machine when the operation simulation operation is there, when there will be any collision between two components, that we are going to see with the help of the visualization, and the preliminary analysis is taken into consideration. Preliminary analysis means in the design software only we are having the analysis option also to check its structural thermal values. Next, what is the engineering analysis? This is nothing but the software of computer-aided engineering, how the engineering analysis and optimization is going to be taken place. The first one is the statistic analysis, kinematic analysis, design for assembly, design for manufacturing, heat flow analysis. Design for manufacturing means, suppose if it is a we are going to if I want to have a pen, we are going to see how to manufacture that particular pen. We are going to design, we are going to give a flow chart to manufacture of that particular pen in a required way. Next is the design for assembly means, we are going for assemblies can be done in different ways. So best optimized assembly, how we can able to produce it. Next, kinematic analysis. When the kinematic means motion between two parts. How this means nothing but a simulation. How it is the simulation operation need to be. Next is static analysis. Static means structural. How the when the load is applied on a particular component, how it behaves, that we need to check it. Next is the heat flow analysis. Heat means temperature. How the component or the part reacts when the heat is generated. When the continuous rotation between the part is taking place, there is going to exist a large more amount of heat. Due to that, the component may melt. We need to check it, that heat, and we need to check the flow also. How the liquid is going to be flowed when the heat is generated. When the heat is not generated, how the liquid is going to be flowed in the pipes or whatever it may be. So we need to check. After that, we are going to develop a prototype model. Before committing to design to manufacture, it is also essential to carry out some physical tests on a part. This will computer analysis. This will be in addition to computerized analysis carried out using various facilities. So nowadays people are using the word rapid prototyping. Rapid means very fast. Prototyping means showcase part or first part, we can say. So I have developed my component, everything computer, based on the computer, everything I have finalized, and I have started the production, and I have given the produced one part by going to the computer aided quality control, packing, everything, and it was finally shipped to the market. So after that, then it will be asked by the individual persons in the market about the feedback of that particular component. So that is nothing but the testing. So some people will give different ideas after the finishing of the product, after completion of the product. If no one attacks it, no one goes to it, likes it, then it will be a failure model. Biggest, if you go, the Tata company has launched the Nano car by the Ratan Tata, one of the biggest failure to that company. What they did? They have analyzed completely, and their aim is to produce 1 lakh rupee car so that the common man also need to use the purchase that car. But when it comes into the market, no one has received the car due to its poor performance. So many reports are also given during the time of introduction of that particular car itself, and the company thought that it will be heated the market as the cost is, but no one liked that car even though it was a reputed company. So such type of things that damaged a lot to that company. So we need to we need to do the prototype model. Once the prototype model was developed, then we need to go for the trial ride or test ride about that particular component for a period of 1 year or few months. Then it need to be released into the market. So different happens are will be there in the company. A prototype component helps in obtaining the necessary information for manufacturing. Next, what is the manufacturing process development? How it looks is, so this is the process plan. Next is the tool design, how we are going to tool design. First process plan, what we are going to do, we are going to send the part. Process plan means when and where the operation of manufacturing need to be done. That is the process planning. Process means there will be some process, because and plan should be there. Process is nothing but a sequence of steps, I can say, a sequence of steps that need to be followed, and plan means we need to give how this operation need to be done. So that is the process planning. Next is the we are going to design the tool, and I told you tool design means to manufacture a particular to done a particular operation. The best equipment is nothing need to be used. This comes for we need to design the jigs, we need to design the fixtures, we need to design the tool holders, we need to design the tools to perform a particular operation on the workpiece in optimized way. So that comes in the tool design. Next is the manufacturing information generation. The manufacturing information generation means we need to manufacture the component, so that information how it was done, what it was done, where it was done, what is the time, what is the temperature to each and every operation. All the complete information should be in the written documented form. That is the manufacturing information generation. Next is the manufacturing simulation. Before producing the part, before going to before going to have the loss on the computer screen, we need to see the complete process from the raw material to the delivery part, about how this part need to be moved on different machines, how the two jigs and fixtures are holding the workpiece, and how the automatic generation of the information was there. That all need to be done in the manufacturing of simulation software. Then once it gives the optimum result, it is okay, then we can go for the production. So that is the manufacturing simulation operation. Information requirement design. So it is one more task, however you need to give, I can't give the information like that. There will be certain procedure process, that is the information requirement design. Next is the time and motion study. To optimize the time and to produce the motion means movement of the component that we are going to do. Next is the production plan design. So this is one more big, I can't, if you go in a big company, in a big company of 100 acres, 200 acres of plant establishment, each where should be the office room, where should be the raw material room, where should be the production room, where should be each and every machine should be there. First, where should be the lathe machine, where should be the tinkering machine, all those things, where should be the painting machine, where should be the quality control, where should be the packing department, and a complete about the plant. So need to be designed in this production plan design. Why? Suppose if I did a at the entrance of the company, if there is a production and the raw material should be dumped around 2 kilometers before backside. So it will be a great loss always to move the raw material from that location to the production. So we need to optimize the design product of a plant also. So this is the general product life cycle. There you can able to see the what is meant by a CAD means. The CAD you can see geometric modeling, finite element analysis, computer design, product proving, that is the simulation, under the computer drafting. This all comes under the CAD package. Whereas the CAM package, you can able to see this screen. In the CAM package, the ordering equipment, computer aided process planning, computer aided tool design, tool manufacturing and tryout, computer aided workstations, computer aided scheduling, computer aided CNC part programming generation, material requirement planning, CNC machines, robots and other material handling equipment, and actual production and computer inspection and quality control. This completely is of the CAM. To combine this CAD and CAM, we are having the computer integrated manufacturing, where we can able to see there. This complete process, the computer aided design and the computer aided manufacturing, and we need to have the computer integrated manufacturing. The combination of the CAD system and the computer aided manufacturing is nothing but the computer integrated manufacturing. In the sim, we are having the robots and other equipment for movement of the tool. So this made us the advantage of CAD CAM made us to produce large number of different varieties models of cars or advancement in all industries. This CAD CAM has proved. So next is the computer aided manufacturing. It can be defined as the use of computer systems to plan. We need to, I already told, to process planning. Manage means how the process plan should need to be there, and control the operations of manufacturing plant through either direct or indirect computer interface with the plant's production resources. We need to control the plant through direct or indirect computer interface with the plant's production resources. What are the applications of a CAM? Computer monitoring and control. These are the direct applications in which the computer is connected directly to manufacturing process for the purpose of monitoring or controlling the process. Either we need to control the process or we need to monitor, means whether how this component was manufactured. And manufacturing support applications also will be used, not only this production from the raw material, to that we need to check the stock in the warehouses. Based upon this we are going to manufacture. These are the indirect applications in which the computer is used in support of the production operation in the plant, but there is no direct interface between the computer and the manufacturing process. So this is how the manufacturing support applications. So computer how this will be this computer monitoring and control. There will be a computer, there will be a process, and we are going to just process the data. We are going to process the data, and based upon the data, and our analysts or the mechanical person or the engineers, we choose whether to proceed further or to stop further. That we are going to do, and we are based upon that we are going to send the signals to the processing department whether to move forward or to be holded. So this is computer monitoring and control. Next is the manufacturing support applications. This is based upon the process data, we are having the control signals. For this, the manufacturing operations can be done. So what is examples of CAM are computer numerical control quad programming. Control programs are prepared in computer for automated machine tools. Computer automated process planning. The computer prepares a listing of the operation sequence required to process a particular product or component, and the computer generated work standards will be there. This is going to determine the time standard for particular production operation. Next is the production scheduling. The computer determines the appropriate schedule for meeting production requirements. So the material requirement planning, here also the computers are used to based upon the stock in the warehouse, whatever it may be, we are going to determine how the production should be there. Next is the shop floor control. In the CAM application, the data was collected from the factory to determine the progress of various production shop orders. So based upon this we are having. So already we have discussed about the definition of CAM tools based upon their environment. Hardware, these are the computers, and for these computers there will be a certain softwares. So these are called computer aided manufacturing tools. And apart from this, we need to have the networking. Networking means we need to be interlinked each and every packages. That is the closed loop circuit, open loop circuit, like that it will be called. So all this need to be interlinked. Next is the definition of CAM tools based on their constraints. One is the networking concept, one is the manufacturing tools, next is the CAD tools. Define CAM tools. If anyone will ask, we need to say that it is the intersection of the networking concepts. Next is it is the networking concepts, CAD, computer design, and the manufacturing tools. When these three are integrated, then it is called as a CAM tools. Without CAD software, we can't have the we can't say that it is a CAM tool. So it is the intersection of these three. So what are the CAD tools and CAM tools? When one asks, it is the intersection of manufacturing tools, design tools, geometric modeling, computer graphic concepts, and networking. These five, when it was interlinked, this intersection is called as a CAD CAM tools. It is the further extension will be the computer integrated manufacturing. So The design and definition of CAD CAM tools based on their implementation in an engineering environment is, one is the hardware. Before that, we need to have the design in the mind or in the paper format, plus manufacturing tools need to be there. For this, we need to have the computers. Not only computers, we need to have the application softwares. For this application software, again we need to have the hardware plus networking we need to have. So this finally gives the CAD CAM tools. So implementation of a typical CAD process and a CAD system is delineation of a geometric modeling, definition translator. However, if someone will say the problem, that should be, that problem need to be understood by the particular person. There should be a definition should be in a particular form. I can't understand the problem of a patient. It will be understood only by the doctor and the pharmacist. So the problem definition to each and every, in similar way, I can understand only the manufacturing of a component or part, but I can't understand the drawing of a civil engineer. That will be understood only by a particular specialized person. So it should be the definition translator, it should be. Next is the geometric modeling and interface algorithm should be there. So finally the design changes need to be managed by design and analysis algorithm. Drafting and detailing will be there. Once the drafting and detailing is there, then the documentation will be produced, then the CAM process is going to be started. So the CAD softwares will be in one country and the machining will be in another country. So you can imagine how the technology has been developed. So CAM tools required to support the design process are process planning, CAD techniques, computer-aided process planning, cost analysis, material and tooling specification. Next is the part programming. We need to have the NC part programming, and the inspection we need to have computer-aided quality control and inspection software, and assembly, robotic simulations and programming need to be there. This is the typical utilization of CAD CAM system in an industrial environment. So in the geometric modeling of conceptualization, there is design evaluation possible with available standard software. Yes means then it goes to the design testing and evaluation. If it no means, again it will be sent to the develop customized programs and packages. When it was okayed, then again it comes to this stage. From the design testing and evaluation, if it is okay, then is final design applicable. So we can say that we can go further. So if the final design is not in that I can able to manufacture, again itself it goes to the no means, again it enters into the geometric modeling and conceptual design. So here it will be rotated and the optimized one will be produced. Once these three are satisfied, then we are going to produce the drafting and the documentation. So when it was there in the process planning department was there. In the process planning, if there are the design what you have sent from this documentation, it again it enters the process planning. From in the database it will be checked whether it was the correct or not. If the design that cannot be manufactured in the machining, then it will be again sent to the geometric modeling and the conceptualization department to verify or redesign the component. Next it was sent to the NC programming. So NC programmers will be there, numerical control programming, where with the programming can be generated in the computer manufacturing softwares. Based upon that, the machining, the actual machining will be taken place. Once the machining will be taken with the help of the robots and the inspection computer-aided quality control department is going to inspect it, the product produced part, and finally the assembly of that particular component will be done. Once the assembly was done, and again it will be verified with the help of the simulation operation, and final process will be taking place. This is the what are the advantages of the CAD CAM system is greater flexibility, reduced lead times, reduced inventories, means stock should be continuous, increased productivity, large number of components can be produced, customer will be happy, serviced happily, the quality of that particular product will be improved communication with suppliers. Supplier means whoever the produced part, different companies will be produced to form an assembly, each part will be manufactured by different company. So this was communication will be much improved. Better product design is one of the greater advantage. Greater manufacturing control, where we can able to control by optimizing the machines. Supported integration, other like jigs, fixtures, all the supporting equipment will be readily and optimized done. Reduced cost, because almost we are reducing the cost of the product. Increased utilization by reducing the idle time. Reduction of machine tools, so one operation on the CNC machine, now we are having the CNC machine. On the single machine we can perform different multiple operations, so that makes an added advantage, and less floor space is the done. Next, this is the CAD. Already I have explained clearly about this product cycle in the conventional environment, how it looks, and this is already explained here. And finally, by this we end for today's class. The main task of computer application manufacturing are generation and management of design information describing the products, and we are going to monitor the manufacturing activities by sitting on a single system. This can be happened only with the utilization of the network system between the computers, machines, and naturally the decision maker, which this finally produces the products. So I hope that this introduction of the CAD CAM was given a better understanding to the students. What is meant by CAD, what is meant by CAM, what is meant by CAE, what is meant by computer aided process planning, what is meant by computer aided quality control. Not completely about the subject, just we have the knowledge about basic terminology we came to understand. By this, today I will end this introduction to a CAD CAM. I hope that tomorrow or day after tomorrow we will further meet on the next session. By this, I thank to one and all for your patient listening.